Hi learners! On this video lesson, you will learn about intersecting lines together with the angles formed at their intersection point except for the right angles. The right angles will be on another video lesson. All intersecting lines here are assumed to be on one plane. Visual representations will be shown to let you understand the concepts easily. Real-life examples are cited to make the concepts relatable and meaningful. Strategies in analyzing and answering simple problems related to the topic are demonstrated to let you gain an understanding on how these are done so that you will be able to successfully answer geometry problems similar to these in the future. If your lesson is on intersecting lines and angles formed at their point of intersection, or if you have an assignment on these topics, or if you are preparing for a test in math, or a test in geometry in particular, or you're someone who's interested in learning math, then this video is for you. Let us start with these learners. What did you just see? You're correct, lines crossed each other. As shown here, 2 and then 3 lines crossed at a single point. These lines crossing each other at a single point are called intersecting lines. And the single point where they intersect is the point of intersection. Though the video lesson is on intersecting lines, rays and line segments, being parts of lines, may also be described as intersecting when the lines containing those parts are intersecting. A detailed description of lines, rays, and line segments, together with how they are named, are on the video lesson entitled Lines, Rays, and Line Segments. The link is down below. That being said, let us have this exercise first to recall our understanding of some concepts. Here it is. Which of the figures below are intersecting? Option A, Option B, Option C, Option D, and Option E. As usual, we begin by reading and examining the whole problem to know what we're looking for, what information are given, and figure out how the given information help find what we're looking for. Okay, what is asked in the problem, learners? Here, we're asked which of the given figures are intersecting. What are given? We're given several figures of lines, rays, and line segments. Okay, so upon examining the figures, we see that some have arrows while others have endpoints. For figures with endpoints, it is easy to see if they intersect. Do you agree, learners? So for option C and option E, we clearly see which pair is intersecting. Now, how about those with arrows? What does the arrow suggest here, learners? You're correct. The presence of the arrow suggests that the figure does not end where the arrow is. Rather, it continues indefinitely. So, to see if they intersect, we will extend the figures. Let's do it. There you are, learners. I think we can now answer the problem. So, which of the figures are intersecting? Is it option A, option B, option C, option D, or option E? Okay, so the answers are options A, C, and D. As mentioned, rays and line segments are parts of a line. So they may also be described as intersecting when the lines containing those parts are intersecting. There you are, learners. I hope you were able to follow. Let us have again these two intersecting lines. We will name the lines and label the point of their intersection. Here, lines N and P intersect at point O. As the lines intersect at point O, a pair of vertically opposite angles marked with arcs are formed. These are called vertical angles. Each angle in this pair has equal measure. So if the measure of one angle is 50 degrees, the measure of the other is also 50 degrees. Since these angles have equal measure, the angles are congruent. Take note that there's another pair of vertical angles that are formed. The measure of each angle in this pair is also the same. One angle has a measure of 130 degrees. So the other is also 130 degrees. Look at the angle with a measure of 130 degrees and the one to the right of it, the one with a measure of 50 degrees. What is common to both angles, learners? Right, these angles are sharing a side and they have a common point. We call the common point the vertex of the angle. Because the angles are sharing a common side and have a common vertex, this pair of angles is called adjacent angles. So any pair of angles sharing a common side and vertex are adjacent angles. Now, let us look at the non-common sides of the adjacent angles. What do you notice, learners? You are correct. The non-common sides form a line. Because the non-common sides of these two adjacent angles form a line, this pair of adjacent angles is also called a linear pair. Now look at their angle measures. Their angle measures add up to 180 degrees. Do you see that, learners? This is one of the characteristics of a linear pair. Their angle measures always add up to 180 degrees. Don't ever forget this. On this diagram, we have several of this. In fact, there are 4 linear pairs here. By the way, are all adjacent angles linear pair? Look at these two figures, learners. In figure 1, the angles are adjacent for they're sharing a common side and a vertex, but not a linear pair. Do you see why? You're correct. Their non-common sides do not form a line. Whereas in figure 2, the angles are adjacent and at the same time a linear pair. So, not all adjacent angles are a linear pair, but all linear pairs are adjacent angles. I hope you were able to get that, learners. Let us look at this diagram again. What is the sum of the measures of all the angles formed at their point of intersection? You're correct, 360 degrees. How about these intersecting lines? What is the sum of the measures of all the angles formed at their point of intersection? And this? So, it will be helpful to remember these, learners. When 2 or more lines intersect at a single point, the sum of the measures of all the angles formed around the point of intersection is 360 degrees. Okay, let us observe this series of 2 lines intersecting at a point producing angles. Here's the first. Here's the second. The third. And here's the fourth. What did you observe, learners? You're correct. Every two lines intersecting at a point form angles of different measures. So when lines intersect, they form angles of various measures. Where do we see intersecting lines, line segments, and rays with their angles in full display in real life? The truth is they are everywhere. Here are some examples containing them with some lines, rays, line segments, and their angles marked for clarity. We see them in our furniture around the house, like a table and a photo frame stand. We see them in roads and city streets, and in buildings and bridges. We see them everywhere. How about you, learners? Can you name other examples? I am sure you will find lots of them. Okay, let us now move on and answer the next sample problem. Here's the problem. Below are three lines on a flat surface intersecting at a single point, forming several angles. The angles are named as angle 1, 2, 3, 4, 5, and 6. The measure of angle 2 is 85 degrees. Which of the angles has the same measure? Option A, angle 1. Option B, angle 3. Option C, angle 4. Option D, angle 5. Option E, angle 6. As usual, we begin by reading the whole problem and may read it several times when needed to know what we are looking for, to determine what are given, and to figure out how the given information helps find what we are looking for. Okay, what is asked in the problem, learners? Here we're asked which angle has the same measure as angle 2. What are given? We're given a figure having intersecting lines with angles formed at their point of intersection. The measure of angle 2 is also given. So we're given here a figure and we are to find the angle whose measure is the same as that of angle 2, which is 85 degrees. Looking at the figure, we see that angle 2 is the angle formed by these two intersecting lines. Though there are three intersecting lines here, we have to focus on these two, for these are the lines forming angle 2. Can you follow, learners? Earlier, we learned that two lines intersecting at a single point produce vertically opposite angles or vertical angles that are congruent. Let us then identify the angle that is opposite and vertical to angle 2. Let's go. So, this is the angle that is vertically opposite to angle 2. This angle has therefore a measure that is the same as that of angle 2. So, what is our answer, learners? Is it option A, option B, option C, option D, or option E? Okay, so the answer is option D. Angle 5 has the same measure as that of angle 2. Let us now go to the next sample problem. Here is the problem. Below is a photograph of a part of a city road map. The measure of one angle formed by the two intersecting roads is 42 degrees as shown. What is the measure of angle X? Option A, 42 degrees. Option B, 90 degrees. Option C, 138 degrees. Option D, 180 degrees. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information helps find what we're looking for. Okay, what is asked in the problem, learners? Here we're asked to find the measure of angle X shown on the photograph of a road map. What are given? We're given a photograph of a road map having intersecting roads forming angles. The measure of one angle is given. Look at the photograph of the intersecting road, learners. What can you say about the angle with the given measure of 42 degrees and angle X? You're correct. The two angles share a common side and the non-common side form a line. What do we call this type of angle pair again? You're right, a linear pair. Now, what is true about the sum of the angles in a linear pair? You're right again, the sum of their measure is 180 degrees. That is, the measure of angle x plus 42 degrees is equal to 180 degrees. To find the measure of angle x, we will subtract 42 from both sides of the equation. Thus, this gives us 138 degrees. So, what is our answer, learners? Is it option A, option B, option C, or option D? Okay, so the answer is option C. The measure of angle x is 138 degrees. There you are, learners. That was again easy. I hope you have acquired lots of learnings in today's video. Let's summarize what we have learned today. We have learned that, first, intersecting lines are two or more lines crossing or intersecting at a single point, forming various angles. The sum of the measures of all the angles formed around their point of intersection is 360 degrees. Second, two lines intersecting at a single point produce two pairs of vertically opposite angles or vertical angles. Vertical angles are congruent. Third, any pair of angles sharing a common side and vertex are adjacent angles. Fourth, linear pair of angles are adjacent angles whose non-common sides form a line and whose angle measures add up to 180 degrees. Fifth, when solving a problem, you must read it and may read it several times when needed to know what you're looking for, to determine what are given, and to figure out how the given information help find what you are looking for. Sixth, when a figure is given, make use of it and modify when needed. It is there to help you analyze and solve the problem. There you are, learners. Hope this video helps. That's it for now. If you have any questions, leave a comment below and don't forget to like, subscribe, and share this video to your peers so others will learn too. Bye.